So we are back and I am recording, and welcome back to CSE 223. So the hand raising thing does seem to work, but I'm not looking at the chat window, so if you need to get a hold of me, raise your hand and or just start talking through your microphone, and that should work pretty well. So I want to start talking about actual Java coding today, and I want to talk more about this idea of classes and objects, and let's make our first class and explore what we can do with it. So alright, so let's make a main program. So our main program, I'm just going to call it main, and it's going to start with our usual incantation, public class main, curly bracket, and then our main program starts with public static void main, parentheses, string bracket, args, close paren, curly bracket. Right, and our main program goes in here. And again, we're not going to worry too much about what this means, but we're going to make a new class. I'm going to call it rectangle. It's going to be a class of rectangles, and that one we are going to take apart and look at what all the different things that we write actually mean. But explaining why we have a public class main up here takes a little bit more background than I want to go into right now. So for now, we're just going to leave this as our main program. And let's make a class called rectangle. So first thing is conventions. The standard convention is classes start with an uppercase. That's not required by Java itself, but it's an almost absolutely universal convention. Okay, when you define a class, it should always begin with an uppercase letter. For example, rectangle, R-E-C-T. If somebody sees that, they assume it's the name of a class. You could have a variable called uppercase R-E-C-T, but it's going to confuse most people because they're going to think it's a class name, not an actual variable or an object. So objects start with a lowercase letter. For example, my rectangle. And after the first letter, you're free to mix uppercase, lowercase, however makes sense to you. Some people will do camel case, where, if you have words in your variable name, you uppercase the first letter of each word other than the very first word. So my rectangle, or, my small rectangle thing. Right, so that's called camel case. Some people use snake case, where you use underscores, but it's just a way to make long variable names. They're still easy to read, right? But it's better than just, R or I or X or things like that. So we're going to stick to this convention, okay? The following is a requirement of Java. If I have a class named Java, it's got to go in a file named whatever that class name is, .java, okay? I can't put it in a different file name. It'll complain when I try to compile it. So I'm making a class called rectangle, R-E-C-T. It's going in a file called rect.java. And so to make this class, you need the keyword class, followed by the name of the class, and then an opening curly bracket. Okay, so case is significant. White space is usually not. I could put class and rect on different lines. I could put the curly bracket where the cursor is right now. I could put a space before or after it. Same as C, right? It's really up to personal style. Here's one other thing, though, that we're going to do. I'm going to put the word public in front of this. And things work even if you don't do that, but it's a habit to get into. We're going to talk later on today about public versus private. Basically, we have the ability to hide pieces of our code from things that might be using our code, and say, I only want you to have access to certain things, which we'll make public. Well, I'm planning to use this code inside my main program. And so my main program needs access to this class called rectangle, so I'm making the class public. Okay, well, what is a rectangle? Well, it's a parallelepiped. It's a four-sided thing, and it's got a width and it's got a height. And let's make those double precision floating point numbers so we can have very accurate rectangles. So double height, double width. There's my rectangle class. Ta-da! All right. So what do we do? I put some comments in. Right, put in your IP protection or whatever, right? So this is a really simple class, so comments are kind of silly. But get in the habit anyway. Right? So your classes are going to be more interesting than rectangles. So you'd want to actually describe what these things mean, but you know, we all know what rectangles are, so silly comments. All right, what can we do with this? Well, we can say, let's make an object of type rectangle. So what is this rectangle going to be called? Let's call it initial. Okay, well, it's just like saying integer I. I'm creating a rectangle called initial. Initial is an object. It's an instance of the class rectangle, which means initial has a height and a width. And so I could do something like initial.height equals 15 and initial.width equals 25. So now I've set up dimensions on my rectangle. All right, so details. So I want to compile my main program that I've just written. Let's compile the rectangle class first. So I'll say javac rectangle, and that'll compile just fine. Let's compile our main program, and I'll get an error message. And the error says variable initial might not have been initialized. So what's up with that? Well, you know, I declared this to be an object of type rectangle, but I haven't done what we call constructing it yet. This is sort of akin to saying, you know, if I have a structure called rectangle, I could say struct rectangle star initial. And I know that at that point, if I start trying to do initial arrow height, right, I'll get a seg fault. This is declaring this variable or this object to be an instance of rectangle. It's saying what kind of thing initial is, but initial does not yet exist, right? It's the name of what's going to be a rectangle, but I haven't actually constructed it. In particular, I haven't set aside the memory for it and changed initial to point to that memory. So that's the sense in which it's saying variable initial might not have been initialized. So I need to actually construct a rectangle. In C, we would do a malloc. In Java, we do something a little more civilized. Just say initial equals new rectangle. So this is calling the constructor of a rectangle. That actually gives initial. It creates a rectangle that causes initial to point to it effectively. We don't talk about pointers in Java, but that's basically what's going on. It's allocating memory, and then initial is referring to that memory location. So once we've done that, now we can successfully compile main.java, except that I made a typo. So now we can compile. and we can run main, and it doesn't do anything because we didn't tell it to do anything, but it is actually setting the height and the width of this rectangle to be what we've specified. So we can say, did this work? Alright, so I'll just use a print statement to see if this actually worked. I'll print out the height and width of initial as follows. I'll compile and I'll run, and not surprisingly it tells us the height's 15 and the width is 25. So this looks like a structure in C, right? There's really nothing special going on here that we couldn't do with just a struct statement in C. We're defining the fields of the structure rectangle, and here we're accessing those fields with this point notation. Okay, here's where it starts to get really fun, is we can start defining methods, functions inside this rectangle class. So for example, what do we want to do with rectangles? Well, maybe we want to find the area of them. Okay, now in my main program I could find initial.height, initial.width, and I could multiply them. But, you know, I have to know that that's how you find the area of a rectangle. If this was a triangle or a five-sided polygon, I might not know that formula. The person who's writing this rectangle class, they'll figure that out for us, and they'll write a method that will let us find the area. So here's what this would look like. So let's just return the area of the rectangle. It's a one-line function, right? Just take the height and the width, multiply them, and return them. Okay? So first thing that's a little strange here is this area function doesn't take any arguments. Right? Now in C we would say something like, call the area function, pass it the rectangle, and do something with the result. But in here, we're not passing any arguments to the area function. We don't need to pass arguments, because we're using the height and the width, and guess what? Those are part of the rectangle. So let me show you how you use this, and this will make a little more sense. Let's find the area. Right? I can print out area of initial equals, and then I'm just concatenating the return value from this function call. Okay, so I'm calling a function area, which is going to, run this code. But what is it going to use for height and width? Well, since I'm calling this function as part of the object initial, when I come in here to area, it's going to use the height and the width from initial. So you want to kind of think of this as this is, a piece of this object. Initial has three things associated with it because it's a rectangle. It has a height, it has a width, and it has an area method. And in the area method, when I refer to height, this is what I'm referring to. And when I multiply by width, this is what I'm multiplying by. Okay, so this is a different mindset, right? This is combining code and data. Okay, so that's one potentially new, slightly bizarre concept, and this works as we'd expect. So area of initial is 375, 15 times 25. And after we've done this, I could change something. I could change the height to 20 and then print out the area again. And so that second time the area is 500 because now it's a 20 by 25. Okay, the reason this is nice is because when we want to deal with rectangles, we're just going to have an object of type rectangle, and it's going to have all the stuff built in for manipulating it, for finding out its area, for finding its perimeter, for example, things like that. Okay, just like we saw with strings. When we defined a string yesterday, we said this string is equal to such and such. It came with a method for converting to uppercase. It came with a method for finding its length, and so on and so forth. Okay, so we're really bundling the functions with the things that the functions operate on. This is something called encapsulation. Okay, it's one of the key concepts of object-oriented design is to encapsulate that functionality in there with the data. All right, so let's expand this. Let's find the perimeter. Okay, bang, we got a perimeter function. And again, it doesn't take any arguments. It does have a typo. Okay, it doesn't take any arguments. But we can just say initial.perim, and it should tell us the perimeter. Right, so the perimeter is 90. So let's go ahead and print out the dimensions. Right, so the new initial was 20 by 25, the area is 500, that's 20 times 25, the perimeter is 90, that's 45 times 2. So if this was something more sophisticated than a rectangle, we could start adding all of the things that we know about it. Right, all the things that we might want to do to a rectangle, we could write methods for, and then somebody simply, defines something to be an object of type rectangle, constructs it, and then they can start using all these methods. Okay, so that's encapsulation. Let's do something about this. Because when we say initial height equals 15, initial width equals 20, initial height equals 20, we're requiring the person to know that this class called rectangle has these things called height and width. Okay, and that's a little awkward. Because maybe I don't want to call them height and width. Maybe I want to call them H and W. So now my documentation has to say, yeah, set the variable height to equal this and so on and so forth. Okay, we can clean all of that up because our constructors can actually take arguments, right? When we constructed a new rectangle, we had a parentheses here after this. Parentheses usually mean a function. Well, this is actually calling a function. It's a special type of function called a constructor. And so I could define something new in here. So let's make a constructor. And constructors, we don't specify what kind of thing they return. Okay, it's the only function we write that won't have a return type like void or double or int or something like that. So public rectangle, integer h, integer w. Let's set the height equal to h. Let's set the width equal to w. And that's all we have to do. Okay, what does this let me do? It lets me change my construction here to say initial equals new rectangle parentheses 15 comma 25. And I don't need to do this business down here, right? I actually specify the dimensions of the rectangle when I construct it. So I can compile that and run it, and it works exactly the same. But this is, arguably a cleaner way to construct a rectangle. So my documentation for a rectangle would say, construct it with rectangle with height, comma, width. And now I don't need to know these magic field names, and so on. Okay, let's make a new rectangle called small. If I try to compile this, I'll get a compile error. Oh, I made a typo too. But if I try to compile this, I'll get a different compile error. It tells me constructor Rect in class Rect can't be applied to the given types. And it's flagging this line down here, and it's telling me I need a pair of integers, and it found no arguments at all. In other words, I tried to construct a rectangle with no arguments, but I'm required to specify 2 integers. Okay, so it's telling me this is invalid. Okay, well, you know, maybe I want to construct a rectangle without specifying dimensions. That's a reasonable thing to do. Maybe I'm going to get some information from the user and use that to set up dimensions. So here's something really crazy that I can do. Let's make another constructor, which takes no arguments. And let's just set up a default height and width of 1. We don't have to, but I'm just going to do that for fun, right? Okay, so now if I try to compile this, it compiles fine. And if I were to print out this small rectangle, I should see that it's a 1 by 1, right? So small has a height of 1 and a width of 1. Okay, think about what we just did though. We made 2 functions with the same name, right? We have a function called Rect and we have a function called Rect. This one takes a pair of integer arguments, this one takes no arguments. Okay, that's legal in Java. It's legal because functions are identified by not just their name, but by the list of arguments that they take. Okay, so this is something we call the signature of a function. Right? So in C, a function is identified strictly by its name. And in fact, if you have a function that expects 2 integers and you call it with only 1 integer, it still compiles usually, right? And it'll still run, and sometimes it'll work fine. In Java, the identity of a function is not just the name of the function, but it's also the number of arguments and the type of each argument. So this function named rectangle, this constructor that takes 2 integer arguments, is a totally different method from this one with the same name, but that takes no arguments. And Java doesn't get confused because if I try to call this thing with no arguments, it's going to call this function right here. Whereas up here, when I tried to call it with 2 integer arguments or 2 double arguments, it's going to call this one up here. I should have made these doubles. But, you know, 25 is an integer and it's a double. But, well, actually, let's play with this. So I mistakenly declared my constructor to take 2 integer arguments. Suppose I tried to construct with dimensions 15.5 and 25. Right? When I try to compile, I'm going to get an error. It's going to say it's trying to convert this to an integer because that's what the constructor wants, and I'm going to lose some conversion, some precision in that conversion. Right, so this I should have declared this to be arguments that are doubles. And then it'll compile and be happy. All right, well, we can keep doing this, right? We could make another constructor for a square. And this constructor only takes 1 argument, so the length of one side, and we set the height and the width equal to that length. And so now if I want to make a new square, right, I could just construct with a single argument. And let's just print out the dimensions of that. So square should be a rectangle that will be 7 by 7. Which I have to spell correctly again. Right? So SQ was a rectangle with height 7 and width 7. All right. So this is potentially a new concept. This idea of a signature. We have 3 methods here in our rectangle class, all with the same name. One takes no arguments. One takes a double, and one takes a pair of doubles. And I could make something that takes a pair of integers, or an integer and a character, or a double and a string, right? And those are all different functions. All right. Well, rectangles, if you think about the height and the width of a rectangle, it really doesn't make sense if these things have negative dimensions, right? That's not really well defined. So we'd like our height and our width to be at least 0. So when I do my constructor down here, I could do the following. If my height is less than 0, let's set it equal to 0. And just like C, everything is passed by value. So if I pass a variable here that's negative and I set it equal to 0, the variable that I passed from outside doesn't get changed, right? This is a local variable in some sense. So so I can do this safely. So I'll make sure my arguments don't get negative. And same thing down here. If you try and make a square with a negative length, I'll set it equal to 0. So let's make a rectangle whose dimensions are 15 and negative 25. And if I run that, my initial has dimensions of 15 and 0, right? It changed that negative 25 to be a 0. And this can be useful because, you know, it may be that if I have a negative inside, bad things will happen. For example, if I wanted to square a rectangle, I wanted to find a square with the same area as the rectangle, I would find the area of the rectangle, take the square root. Well, if one of my edges has a negative length, the area is going to turn out to be negative and the square root is going to blow up. So I would prefer not to have negative dimensions inside my rectangle. All right, but, you know, a savvy user might do this. They might just go in and they might just set that width field to be negative 25. And now when I run my code, guess what? I got all these negative areas and negative perimeters and weird things like that. Okay. So that's a problem. This is how code breaks. Because users get smart and they start tinkering with the internals of data structures that they shouldn't be tinkering with. So in 222, we talked about abstract data types, right? We talked about this sort of firewall where we have, say, a linked list. And the user can say init and add and remove and search and delete, or, you know, reset and so on. And in here we have like sentinel node, and we have something arrow something, and we have malloc and all this kind of stuff. And the idea of a linked list as an abstract data type is the user interacts with the linked list by using these functions, right? The user never says, you know, root node arrow next arrow data, right? The user says, you know, node number 2 or node number 3. We'd really like the user not to deal with our data structure at this level. If we implement a stack, we want to give the user a way to initialize, to push, to pop, maybe to see what's at the top of the stack, maybe to reset the stack. We really don't want the user coming in and saying, you know, SP++. Because this week maybe we increment the stack pointer to push, next week maybe we decrement the stack pointer to push. And if somebody's written their code and they think they're pushing by saying SP++, right, their code breaks, our data structure gets messed up, and so on. So we'd like to avoid having a user do something like this. And it's really easy to do. All we got to do is add some keywords here that say private. And if we make these things private and then we try to compile our program, we'll get tons of errors. And these errors are saying width has private access inside rectangle. You're not allowed to do this. So the only way that the user can set the width of the rectangle is by calling our constructor, and our constructor is going to make sure that that width is not negative, and if it is, it's going to do something appropriate. Okay, this is called information hiding. It's another key piece of object-oriented design. Encapsulation and information hiding are the two biggies. Information hiding says we can take pieces of our structure and prevent the user from seeing it or interacting with it. Now the user still has a way to set the width when they construct. They can pass that argument, that'll be the width of the rectangle. And if it's not a negative number, that'll be the value of this field. But they can't come back later on and specify the width by, you know, explicitly setting it. But we've created a small problem, which is the user wants to see what the height and the width are so that they can print these things out. And they can't see those right now because we've made those private. So we need a mechanism to let the user read these values but not write them. And there's no such thing as private for write and public for read. But we can make that happen by using what's called a accessor. So we'll add some accessors. How do we make an accessor? Well, basically, inside this class, right, everything in here has access to these fields. They're private to anything outside the class, but inside the class, we can absolutely access these things, right? That's what we do when we give them values in the constructor or when we calculate the area and so on and so forth. So we're going to make a function called getHeight. And it's just going to return the height. And we'll make another function called getWidth that returns the width. So these are called accessors, or sometimes they're called getters. And now instead of just saying small.height, we're going to say small.getHeight. It's going to run this method called getHeight on the small function, on the small object, which will run that code which has access to the height and will return the value of it. So I'm going to replace all of these. And I'll replace these with getWidth. I'm going to clean up my code a little, just to encourage you to do the same as you're writing code. Right? Because wide code is kind of hard to control. If you look at it on a smaller screen, it looks kind of you know, messed up indenting wise. So I'm just making things that are longer lines, a little easier to read, right? It's pretty clear from this blank here that this is a compound statement. And if I had multiple things, you know, if I had 80 things I wanted to print, I could put them down 1 or 2 per line. And it's just, you know, playing around with the style. So this should work unless I missed something. So, oh, I went up to 15 errors. That's pretty good. So methods other than constructors have to declare what type of thing they're returning. That's a basic compile thing. And I messed up my get width. We'll get there. All right. So we're all good except that we're still trying to set the height to 20 down here. So let's get rid of that for now, and we'll talk about how to do that in a moment. So typos aside, we've changed these direct accesses to height and width to use these accessors to run these methods called getHeight and getWidth. And that compiles finally, and we run it, and it works exactly as we expect. All right. And you notice my initial had an area of 0 because I constructed initial without any arguments and I didn't specify a height and a width. Well, my default constructor that doesn't take any arguments hold on. Oh, gave it a negative 25, so the width changed to a 0. That's fine. Okay. So suppose we do want to set the width or the height, right, from our main program. Well, we can allow that to happen in a controlled way. So we can make what are called mutators. So we don't need a value back from this, but we can say set height, and we can pass it an argument h. And let's make sure it's not negative. And then let's set the height equal to h. Okay, so there's a mutator for letting an outside entity control the height of a rectangle, but it's in a controlled fashion, right? If they try to make it negative, we'll ignore their request and just make it 0. So there's a mutator for setting height and for width. These are sometimes called getters and setters, or accessors and mutators. Same idea. So down here, instead of doing initial.width equals negative 25, let's make it something reasonable. So initial.setWidth, and let's change that width to 10. Okay, so we constructed this with the width of negative 25, but now let's go ahead and change it to 10 by using the setWidth mutator. And compile that up and run it. Now initial has an area of 150 because it's 15 by 10. Okay, so we've got a bunch of things going on now inside our class, right? We've got privates, right? Information hiding, so we can keep the outside user from getting to fields in an uncontrolled way. We've got mutators and accessors to allow controlled access to and modification of those private fields, right? You're not required to have those, but if you want the person to be able to interact with certain variables, you can do that by setting up accessors and mutators. And we've got multiple constructors with different signatures for creating our rectangles, and we've got a pair of methods for area and perimeter. All right, let's do one more thing. Let's see, which one should we pick with? Let's play with initial. Let's print out the value of this rectangle called initial. Okay, initial is a rectangle. I'll go ahead and change the height to 20 here, since we tried to do that before. So that should be a 20 by 10 rectangle. What's going to happen down here, right? So I've said this plus sign is a concatenation operator. It takes a string on the left and the string on the right and jams them together with each other. And if the thing on the right is not a string, for example, if it's a double coming back from the call to perimeter, it turns it into a string. Well, we know how to turn a double into a string, right? You put a minus if it's a negative number, and you start writing out digit by digit, and you put a decimal point somewhere, and so on. But what is it going to do when we try to take initial, which is a rectangle, and turn that into a string? Well, it's going to print out this funny thing. Rect, which is the name of what type of object this is, and then an @ sign 4AA298B7. And that's kind of like a memory address, and this is kind of like the name of the class that this object belongs to, and this is an internal representation of what that object is. It's useful to the Java virtual machine. It's not terribly useful to us. We'd like to see something more reasonable. So it turns out there's a way that we can control what happens when we ask to concatenate this rectangle to a string. And so this is where we come to the toString method. And this is a part of PA1. We're going to talk about PA1 tomorrow. But this is a part of PA1. toString is a method that takes no arguments and returns a string. And when you have an object and you try to concatenate it to a string, what the system does is it tries to call this toString method, and whatever this returns, that's the string that gets concatenated. Now for doubles and for ints and things like that, there's a built-in toString method. It turns out for rectangles, there's also a built-in toString method. We didn't write it, it came for free, and what it does is it returns the name of the type of object, Rect, an @ sign, and then this internal address. But we can modify this. So what should we do when this gets concatenated to a string? Well, we're going to make a public method that returns an argument of a value of type string. It's called toString. It doesn't take any arguments. And I'm just going to return my usual ha ha ha. Well, if I run this, it tells me initial is equal to ha ha ha. So I have overridden the default toString method with my own toString method, which returns this. Well, ha 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 is not terribly useful, it's entertaining, but let's return something better. Let's return this string, a rectangle of height, appended with the height, appended with and width, and appended with the actual width. And again, I have access to these because I'm inside the class, so even though height and width are private, right, I have access to them because this method is running inside the class. But now, when someone tries to turn a rectangle into a string, it should get changed into the string, a rectangle of height, blah, and width, blah. So now compile your main program and run it again, and it tells me initial equals a rectangle of height 20 and width 10. And this is really powerful, right? This means that we can make very complex objects, classes, with a lot of stuff going on. But we can provide a toString method that a user can use to print out some reasonable representation of whatever this object is. So if I made a linked list class, I might make a toString method that shows you the contents of the linked list separated by commas. And then my main program could say something like, list L equals unquote plus, root node, and that would be replaced by the traversal of the list. So toString is a really powerful thing, and it introduces the idea of overriding methods that already exist. Because there was a toString method that was being called. It's inherited from an object called object, a class called object. But we've overridden that ourselves. So we'll talk about extending classes another time. We saw it a little bit with MyFrames yesterday, but we'll talk about those on their own another day. Okay, so these are most of the pieces that you need to do programming assignment 1. And we'll look at PA1 tomorrow, and we'll go through some examples of using this even number class that you're going to develop. But basically, you know how to create a class, you know how to create fields inside there, create methods, make a toString method. So you've got the mechanics of it. So we'll start working with some of the details of this tomorrow. Make sure you turn in PA0, PAA, by tomorrow morning. I think it's 8 o'clock, I said, was the deadline. Make sure you do that. I've gotten emails from a number of people to double check their assignments, and I've done that, but I can't do a lot of that in the 11th hour. So if you haven't already done your first programming assignment, do it like right now, like right after class. Alright, so we'll dig in PA1 tomorrow. Got a minute or two left. If there's any questions, go for it. Otherwise, I'll end this here. I'll post this code up on Canvas. I'll post the video. So I am recording video and posting it so far. I think I've got that nailed down. So just a heads up to people. These are being posted on YouTube, but I'm not showing anybody's cameras or anything. So, all right. Any questions? All right, well, have a good rest of the day, and I will see you tomorrow.